Assalamualaikum warahmatullahi wabarakatuh. Okay, today our company will present to you about our problem. Okay, first of all, I would like to introduce myself. I am Ahmad Syamil bin Abdullah and I'm the general manager.
Okay, my name is Muhammad Shukri and I am a secretary of the group.
My name is Izham Azrai and I am the IT manager.
My name is Muhammad Zafar bin Mahzir and my position is the engineer.
Okay, secretary, you can start.
Assalamualaikum and greeting to everyone. For today's meeting, we would like to discuss a little bit about renovation that we're gonna make by our company. I really appreciate that everyone concentrate to find some space to participate in this urgent meeting. The purpose of this meeting is to find out an idea or solution for some problems regarding to our company renovation and to make some improvements at working space for a better working environment. For the further explanation, I will pass this meeting to General Manager to explain more details about the problems.
Okay, thank you, Mr. Shukri, for the short briefing. Okay, first of all, I would like to thank all of you because able to join our urgent meeting today. Okay, before we go to the main discussion, I would like to inform you guys that our company will do some renovation. The renovation will involve our computer arrangement and IT department. Before the renovation start, I would want to know our floor area size first, including our main computer area. The first problem is, can the engineer and IT manager present to me the size of region between three computers that have different place coordinate that had been connected to the network cable, because we want to do renovation at that area. The next problem is that is our second problem is about IT department working space renovation. That is about Encik Azrai as the IT manager. It's about we want to increase the working space at the department. Okay, what is your idea, engineer Encik Zafran?
Okay, thank you Mr. Shamil for the problem briefing. Okay, our team, which is engineering department, already discussed about this kind of problem, and today I will share to you our solution to solve this problem. Okay, the problem is to find the size of renovation region that placed in between of three computer that connected with the network cable. Okay, before I further the presentation, I will share to you the four main point that I will present to you. The first is computer coordinate and equation, explanation. The third is solution, and lastly answer. Okay, for computer coordinate and equation, the computer place is the triangle with vertical with coordinate 0, 0, 1, 0 and lastly 1, 3, oriented clockwise. Renovation region is inside the triangle of computer coordinate. Okay, our engineering department already come up with the equation, which is the integration of square root 1 plus x power of 3 dx plus 2xy dy. To solve this integration, we, the engineering department, using the green theorem to evaluate the renovation region. Okay, for explanation, the curve of computer can be thought of the union of three line segment, which can be parameterized easily, but doing the line integral directly would be hard. This because the square root of 1 plus t power of 3 dt cannot be integrated. But green theorem convert the line integral to a double integral over the renovation region enclosed by the triangle, which is easier. Okay, like we calculate by referring to the equation below.
Okay, the equation is P equal to square root of 1 plus x3, Q equal to xy, theta Q over theta x equal to y, and theta P over theta y equal to 0.
Okay, for the solution part, okay, by using the green theorem, our line integral become such as the equation stated.
The equation is integration of P dx plus Q dy equal double integration of theta Q over theta x minus theta P over theta y dA equal double integration of 2y dA. We parameterize the renovation region so that we can set up the limit in the double integral. Traversing the whole renovation region this way, let x vary from 0 to 1. For each x, we let y vary from 0 to wherever it hits the slanting side of the triangle. Now that the side is given by the equation y equal 3x. So the maximum y height we need to go when we are at x is 3x. So the limit the integral become the double integration of 1 0 3x 0 2y dy dx.
Okay, lastly, the answer part. In this part, we will come up with the final answer and solution.
Notice that dx is on the outside since we are varying x first, and for each x we then vary y. We can evaluate this integral by 1 0 3x 0 2y dy dx equal integration of 1 0 y power of 2 3x 0 dx, and the answer will be integration of 1 0 9 x power of 2 minus 0 dx equal to 3x power of 3 1 0, and the answer is 3 meter. So the answer is 3 meter for the renovation region.
Okay, that's all from engineering department regarding to the problem number 1. Next is we will continue with IT department, which will solve the problem number 2.
Assalamualaikum warahmatullahi wabarakatuh dan salam satu Malaysia to all of you here today. Firstly, thanks to the Secretary Mr. Shuk for addressing the matter of this meeting today, and thanks to General Manager Mr. Shamil for being here to discuss the matter. Also, thanks to our engineer Mr. Zaf for a very thorough explanation. I am pleased to present the development as stated in context of IT department workspace renovation. Without further ado, I would like to bring everyone up to speed on what is the development of IT department workspace. Now, we are aiming for a space-saving working environment by positioning the electrical socket outlet and switch box in correct manner by applying a mathematical theorem called the Green Theorem. This discussion is divided into 4 steps, which are problem statement, the coordinates of 4 electrical socket outlets, the equation applied, and the solution. The problem statement is as stated. To place the switch control box at most ideal position, we must obtain the size of region C. What is the size of region C? Next is the coordinate of each 4 electrical sockets outlets are given by 1, negative 1, negative 1, negative 1, negative 1, 4, and 1, 2. This is the equation applied for this scenario, which is the integration of function 6y minus 9x dy minus yx minus x to the power of 3 dx. Lastly, the solution to the problem. From the integral earlier, we have p equals to x to the power of 3 minus yx and q equals to 6y minus 9x. Remember that p is multiplied by x and q is multiplied by y. Also, do not forget the sign. It is easy to assume that p is the first term and q is the second term in the integral, but that is not the case here. Applying Green's theorem, the line integral then equal to 6y minus 9x dy minus yx minus x to the power of 3 dx, then solve further to the double integration of x minus 9 dA. By verifying the previous equation, the line along the top of the region is given by y equals to 3 minus x. The limits are set to outlet 1, which is 1, negative 1 as stated. Finally, by evaluating the double integral, assuming D enclosed in region C, we will have the final distance of negative 218 over 3 meter space-wise. Now, we can prove that we can locate the position of the box to our desire and show it distant between the point of our socket outlets. This is all I can resolve as for the matter of problem number 2. Thank you so much.
Okay, after hearing all of your opinion, I believe to solve both problem is we can use Green theorem. For problem number 1, we get the region between the PC, between the 3 PC is 3 meter. So by referring to the PC coordinate and the equation, we had find the PC region area by using Green theorem method. For problem number 2, that is about the working space renovation. We had find the answer and the measurement about the working space renovation that we want to improve at the IT department. Okay, I think we had solved both problem and we can proceed with the next step. If anyone have any argument,
No.
think engineer and the IT manager already proposed a very good idea to solve the problem. Okay, I don't have any argument.
okay,
I think I don't have any comments on the current matter. So I think they did a good job. We all did a good job.
So what I can conclude from this meeting is Green Theorem is the chosen method that very useful to solve both problems, since the problems need us to find the specific size of the area that need to renovate. Um, all the problems were successfully solved, and thank you to everyone for spending your time to join this meeting. That's all for today meeting. Hopefully everything's gonna be okay as we planned. Thank you.
okay.
Yes,
Thank you for all the stuff.
Okay, thank you.
Okay.
You all for the
Every-
meeting today.
Okay. We end our meeting today. Okay. Assalamualaikum.
Waalaikumsalam.